don't understand why I cannot done full screen. Uh-huh. I understand. Example. Let S sub n, it's the sum of xe, be a random walk, where the x is the identical distribution variables, random variables with mean mu. Do you know about a random walk, Sophia?
Yeah.
Yes. In this picture, you remember I explained about delta 1, delta 2, delta 3. Yes,
Yeah.
you remember. And in this case, we can write that our S what is this? Sorry. Sorry, maybe I try again. And in this case, we can write this as is Sm equals S0 plus sum this delta n. Yes, you remember delta n was the difference between the next and previous, and this process is called random walk if this delta is independent, so covariance equals 0, and the mean in general is 0, 2. So in this example, we have that this x, as in my previous example, it was delta, but this x, it is have mean mu, and let m sub n will be a difference as n minus n multiplied to mu. So we constructed the sequence in that way, and we state that this Martingale, and why we would like to prove that. For proving that, we consider m sub n plus m. What is m n plus m? M plus m. Mn, it's Sn. Sn, it's sum from 1 to n, but now it will be this sum from 1 to n plus m, yes? This xy, and minus, but n in this case it's n plus m, n plus m it is in brackets and mu. Yes, and we would like to find this expectation. So it is it's exactly that I write, and um, and after that we find a mathematical expectation of this sum of these two terms as the mathematical expectation of sum minus a mathematical expectation of this term. But its term, it's constant, it's not random variables n, m, and mu. So we can write this without a mathematical expectation. And after that, this sum, it is sum from 1 to n plus m. We can divide by two sum from 1 to n and from n plus 1 n plus m. But all information from moment n is known to us. So it's not random variable. So mathematical expectation of this we can rewrite without mathematical expectation. And we have mathematical expectation only for this sum. But for every x in this sum, we know that the mathematical expectation, it is mu. And how much mu we have? N plus 1, it is first value, n plus 2, it is the second, and so on. And we have m, this value. So this mathematical expectation equals m multiplied to mu. And so we have this and this. It is will be 0, and sum as xe plus mu. It is minus n mu. It is according definition. It is mn. So we proved that the expectation at the next moment n plus m equals the value in the current moment. Is it clear?
Yes.
Clear. Thank you. And the next example, a Martingale betting strategy. For example, we have random variables with probability, and for every this random variable, we have that this random variable, it is random because it has take only two values, 1 and minus 1, and that's all, only two value. And first value with probability 1/2, and the second value with the same probabilities. Oh, sorry. Sorry. I would like to clear this my drawing. For example, we can imagine that X E representing the result of coin flipping game. Um, uh, win we win $1 if coin comes up heads, and we lose $1 if coin comes up tails. Um, And if you would like to play in this game, we consider now we choose a doubling strategy where we keep doubling the bet until we eventually win. Once we win, we stop, and our initial bet is $1. Um, for example, and now we consider the result this game when we win on the n equals 4. Uh, on the on the start of this play, our bet is 1, and if we agree that we win only on the n equals 4, so for n equals 1, it's our loss, so -1. Agree? After that, we say we double my bet, and it will be 2, but we'll lose again. So we lost 1 and 2, and total loss is -3. Uh, we double bet, it is 4. And we less and we loss again, so our loss is 1 plus 2 plus 4, it's -7. And we double again, but for n equals 4 we win. So we double bet, and bet will be 8, but we win. So if we win, that the value of our win 1, but uh, but 8 it is total value on the table, total value of bet 8, but 7 we lose. So um, uh, 8 minus 7 1, and 1 is our win. So you see that the set of win may be -1, -3, -7. In general, we can, in common, maybe we can write this as sequence -2 to the power n plus 1. Yes, if n1, it will be -2 plus 1 first value. If n2, it will be second value. If n3, yes, we check this, and it's correct. It's correct. All one. So only two value. So first note that our win belonged to this set, only two value, and you saw that, but we can prove that our loss it is with minus, and in the bracket we write 1 plus 2 plus 4 plus plus 8 and 4 and minus 2, and if we win on the finally, so plus 2 and minus 1. But if we not yet won after n bets, it will be this value will be with -2. And after that, we should only to compute this value in brackets as as a sum of geometry progression. And you remember this formula, b1 multiplied 1 minus q to the power n divided by 1 by minus q. And we could check that it will be this value. So the result will be 1, and you saw it as this picture. But if we not yet won after n bets, it will be this value. So to show that it's Martingale only need to show that then expectation of the next value, if we know all information for this moment, and it is the value in the current moment, and we can show that there are two cases. The first case, it is that the Wm equals 1, so we win again. So if we win, we have 1, so for this the next moment it will be only 1, and that's all. But if it is not 1, so we double bet. It is bet 2 to the power on n on n plus 1 toss, and there are only two possible values in this case, and all these possible values with probability 1/2. So we should compute mathematical expectation. We remember how we can compute mathematical expectation. Value multiplied probability plus value multiplied probability. Yes? So you see that in this case we have Wn2. So we proved that this process is Martingale. Process of betting strategy is Martingale. And there are another interesting example for polar soup. It is it is considered a node which contains red and green balls, and in this case it is only one red and one oh, and one one green balls. Yes, in the wood. At each time step, a ball is chosen randomly from the wood, and you see, if ball is red, then it's returned to the wood with additional red ball. So initially we 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 had we had we had only two. Yeah, maybe maybe again attempt. So we have one one red and one green, and we choose the ball. If the ball red, we return a red ball with additional red ball. So red ball will be how much, Sophia? How do you think? One. Uh-huh. If this ball red, then it's returned to the urn with additional red. Red. So this ball, if it's red, he returned with additional. So will be not one, but two red ball, yes, and one green, and one green, yes. But if we choose green ball, so we return this green with additional green. So one red, one red, and two green. Yes,
Yeah.
and let xn denote the number of red balls in the urn after n draws. Then the probability probability to choose the red ball will be car if there are car will be car divided by n plus 2. Why n plus 2? Because the initial moment will be two balls on one red and one green, and for first step will be three ball plus 1, 2 plus 1, 2 plus 2, 2 plus 3, and for n steps it is 2 plus n. Yes, and our aim show that xn divided by n plus 2 is Martingale. Uh, for this, I draw for you this urn, and for first moment the first number it is red, and the second it is amount of green balls, and this red and this green, if it is grow up it is red, and this green. So if we choose the red, it will be 2 1, but in this case we add to the green. And after that, from this urn, we choose again one ball, and there are two cases again, red and green. If it's red, so we turn with additional red, and it will be 3-1. But if it is green, so we return with additional green. Green, it is the second number. Yes, second number. And you see that this case coincides with this case if we go from this point to this, and so on. And at the moment, after n steps, we have, for example, k red balls, red balls, and the total sum n plus 2, no, 2 plus n, I explained. So the total number of green balls n plus 2 minus k. And in the second time, there are only two cases. It is a case for red and for green. And the probability to choose red if we have car red, and the total number n plus 2 is car divided by n plus 2. But probability to choose green, it is n plus 2 minus car divided by n plus 2. And if we compute mathematical expectation, this value multiplied probability, this value multiplied probability, it will be this value. And this example I propose at the task from this lecture. No, not from this. This I explained about xn, but we would like to show that the Martingale mn, xn divided by n plus 2. So from this xn xn its number of red balls divided by n plus 2. Number of red balls 1 divided by n plus 2, it's the sum. It will be 2. In this case, the sum 3 and red 2 divided by 3. And this is the sum 3 and red 1 and 1 divided by 3. Do you understand? Now, for example, how we can get in this case, Sophia, the total number, total amount. Sophia, what is total amount?
4.
The total amount. No, 3 red and 1 green, total amount 4.
Yeah, I said so. 4 balls.
And yes, and 3 red, so 3 fourth, 2 fourth, 1 fourth, and so on. And for this slide, you should prove that it's Martingale. So you should to find mathematical expectation. We have this two value, and we have probability, and we should multiply this value by this probability and find sum. And what is very important for for our theory, it is that discounted stock price in binomial tree is Martingale, and it's easy to prove. When on the previous lecture we considered that mathematical expectation for S on the step n, for example, or yes, on the step n or on step s n plus 1, and you remember this formula, and it is Sn multiplied to 1 plus r. And if you remember, we compared this with S0 multiplied, sorry, and UQ plus DQD, it is 1 plus r. It is our main conditions. And after that, we divide both the side by 1 plus r to the power n plus 1, and this is cross. It will be 1 plus r to the power n, and this it is not changed, and we rewrite this in this side because we can write constant under the sign of mathematical expectation, and you see that we proved that mathematical expectation for discounted stock price to the next step n plus 1 equals discounting stock price for the step n, and it's our aim for today was to show that really efficient market hypothesis provides that our process is Martingale. And that's all. Thank you for attention. And maybe you have any questions. If don't, so you can open a problem for this lecture and do this.
Okay.